Today again we will start with the Jupyter notebook. So again you have your Anaconda, and then you can work either by using Spider or you can work with Jupyter. So I'm using again Jupyter, since the reason is that I can share, there will be notes and I can share with you those notes. That will be easier. So just a second. So we create a new file, Python file again, and we give the name here. You can see it. So we can give the name Python, let's say lecture 2, Python session 2. So this is the name. Okay, so yesterday what we did, we covered basically how you can use Python as a like calculator, where you can do many scientific computation. For example, calculating the value of sine, tan, math, exponential, log, and every other thing. So you can practice that. Then we discuss about the Python data types like integers, floats, Boolean. Then we talk about other thing, for example, list, tuples, strings, dictionary, and others. So today we are going to start with the actually looping in Python. So loop in Python. So there are two main important loop. That is, one is for loop, and then another is a while loop. So for loop and you can say that while loop. Okay. So how you work with the for loop? So for, this is the direct commands for item in, and then you can put many things here. You can put a list here. Let's say 1, 2, 3, 4, 5. So it will iterate all the value here for item in 1, 2, 3, 4, 5. And then you can print the item. So this is one way of writing this. So what you are doing, you are basically using for item in 1, 2, 3, 4. And item is just, you can use anything here. Item is just a word that we have used, but you can use any other thing, whatever you want. So this will print everything here. Now similarly, you need not to write item here. You can write, let's say, for x in 1, 2, 3, 4, 5. And then you have to write here just print x. So item is just one thing. You can use whatever you want. This still the output is same. Okay, so and then the important thing is what you can use here. So you can use any iterable thing. You can use any iterable thing. For example, you can even, the list is an iterable thing. A string is also an iterable thing. For x in some string, so I am saying some this string, and then you have to put a colon, you enter, and this is the standard way, print, and then you write x, and then shift enter. So in this case, what it is doing, it is basically iterating all the basically elements in the string one by one. So D, G, and in this way. So it is doing the iteration on all the elements in the string. Okay, you can use for, let's say, x in tuple also. There is, you can use this 1, 2, 3, 4, 5. This is also an iterable thing. So print x. So we are using as a tuple, no, not a list. And then you have again the output. So this means for loop basically it work x, it take basically all the elements in the iterable, whether it is a list, it is a string, it is a tuple. So you can iterate here, and then you can have other things also where you can do the iterations. Okay. So this For loop is very useful when you want to basically study the elements or you want to do some operations on the elements, then you can do it. Then sometimes there are, let's say, range functions. You know, range function is there in Python that is we use sometimes. So for example, range 5, let's say we calculate it. So it will do, okay, range is giving 0 to 5, let's say range 0 to 5. So it should give actually the value here. So let's say for, let me just see how it is doing for item in range 5. Basically, we want print item. So for example, you can use range function. If you put a, let's say 5 here, it will generate the number from 0 to 0, 1, 2, 3, 4 in this way. And if you change it from, let's say you can change in this way, 1 to 5, I think, then it will start from 1 and it will not go to the 5 basically. It will go 1 by 1 to 4, right? So it will basically print 1, 2, 3, 4. So by using this, essentially you can write a, let's say, factorial function. So how to write a factorial function? Factorial function, which that calculate the value of the factorial. So last time we discussed about the function definition, and as well as we discussed about the, essentially we discussed about the, we also provide basically, we also know this for function. So let us start. So how to write it? Let's say we write definition. We want to write a factorial function that take factorial. Let's say this is my function factorial, and that takes some value n inside it. It need a parameter n, and then what it does is basically multiply n till 1. Okay. So what you can write? So you can do it in this way. So for, you can write in this way. Let's say some, you can do either this way. You can decide first x, let's say x is equal to 1, some value, and then you can write in this way for item in range, and then you want 1 to n plus 1. Since we want, it will go till 1 to n only, and then you can write what you write. X is equal to the previous value into item. So x is start from 1, so it will start basically generating 1 to n plus 1, and you can write x is equal to x into item, and then it will return the value x, right? And then what you do, you say so you write here, and ultimately what you have to do, you this value you will get, and ultimately what you have to get is return the value x ultimately. So essentially another thing you have to understand is that there is a this space thing. So whenever you write a definition, so this there is a space here. So this means there is a space here. So we have given this is called a for space essentially, or a tab button you can use. So here you can see that 1, 2, 3, 4 we reach here. Then your loop start from here. Then again in for loop you have for space here. automatically takes actually 1, 2, 3, 4. And then return is actually outside this for loop. So that's why we have written it here, return x. And this is inside the definition, but outside the for loop. So inside the for loop, only this computation happen as x is equal to x into item. And the return is outside the for loop, this one. And this is our return factorial function. And then you can calculate it factorial. Let's say I want to calculate 3, right? So the value is 3 into 2 into 1. So that is 6. Similarly, you can calculate, let's say factorial, some bigger value, you can give 4, and then you have 4 into 3 into 2 into 1. That is factorial 4. That is 24. And then obviously as we write that, the good practice is that you write what it does. So you generally we start with the triple quotes and you write that this function. So we can write in this way, description. This could be, you can follow this function, or simply returns the factorial value, and then input basically integers, positive integers, you can say positive integers. And then what is the output? This function give basically again integers. The output will be also integer. So in this way you have a small description of the function, and then whenever a new person come and then he see that okay, you have written some function, whether they can use it, so they can say that okay, factorial function, what it does, if they don't know, they press the question mark and they enter here. So they see that okay, there is a description of this function that is coming down. I'll keep it on the top. So this is a factor definition that okay, this function, just I'm setting. Okay, so this function returns the factorial value, input positive integers, output integers. So you can see it here in the help, in the basically doc string. And the good part is that if you have a big module, in just 1 or 2 simple commands, you can make the whole doc string out of that. And that doc string you can use as a document for your like description of the different functions in your module. So that is very good thing. So you can keep collecting this, and then you have the whole doc string which become a big document, and then that can be used to describe your functions. So this is the basically we have used here the for loop. Now we go to the while loop. So just I take one space. So we use the while loop. So just directly I'm writing that how do you use the while loop. So while, let's say you have, this is a Python keyword that comes while x, let's say less than 10. So if this condition is satisfied, this condition, while x less than 10, and then you have to basically start x from somewhere. Generally we have a starting point and we take, let's say 0. This could be the starting point. So x has a value, initial value, that you have to take it some value so that it understand that okay, x has taken some value. Then you can do many things. Whatever you want to do, you can print x. This is just simple thing we can do. So while x less than 10, print x. So if I do it, so it will enter a infinite loop. Since what will happen that there is no change in x, so every time x is less than 10, it will keep printing and it will keep running infinitely. So that we cannot do. So you generally what happens that we have to make some change in x. So let's say x is equal to x plus 1. So after printing x, it increases the value of x by 1, and ultimately it will keep printing till this condition is satisfied, and then it will exit automatically the loop. So in this way you can see that if I do it, So initially it say x is equal to 0. So it go here, it say that, okay, x less than 10. Yes. So print x, this is the 0 value. Then what it does, it say that, okay, increase x by x plus 1. So it become 1, it go back, 1 is less than 10. Yes. Then it print, it become 2. And then ultimately when x is equal to x plus 9, after printing till 9, when x, this become, x is become 9 plus 1, that is 10. So 10 is not strictly less than 10. This is less than 10, not equal to 10. So it will not print 10. It will print till 9. So that's how it works. While, so suppose I change it little bit. I make it. So let me do it. So let x is equal to 0, and instead of printing x here, what we do, we first do the increment and then print x. So remember that in this case, the situation is different. You are first printing x plus 1, and then you are first making the increment and then printing. So this means what? So it will not start from 0, it will start from 1. Since it start from 0 and then it will say the 0 less than 10. So then it will increase. It will increase basically the value and print it. So this will start from 1 onward until 10. So this is slightly different situation, little bit. So in this case, you first make the increment and then print it. In this case, you first print it and then make the increment. So you have to understand that how this is happening. So this is the while loop. Again, we can write the factorial function using, let's say, while loop. While loop, you can do it. So again, you can write I can say that my factorial 2 actually. This is a new function. So we'll give the name. And then it also take integer value n. And then you can start with, let's say, some value x is equal to 1 again here. And then what you say, you can use while loop. So while n is, or okay, while n is greater than 1, while n is greater than 1, you can write x is equal to n cross x, and then what you write, n is equal to n minus 1. So you keep decreasing n. So you multiply, let's say n is some value 10. Then what you do, n is greater than 10. So this satisfy. So you say that x is n into x, 10 into 1. And then what you do in next, you make n to be 9. And then you check the condition, and then you keep doing it until you n become basically 1. And then when n become 1, it doesn't satisfy the condition, so loop automatically get out, and then you have your, and what you do here, your value will be return x here, right? So this is your new function. So you can, I'll share these notes with you, so don't worry. So you try to understand this, and then you can practice yourself. And then let's say again 4. Okay, what is the issue? Maybe I have written something wrong. Maybe return n is equal to return x. X is equal to 1 definition. Just let me see what is the issue. It's saying that Local variable x reference before assignment. Okay, okay. N is equal to, while n is greater than 1, x is equal to n cross x. What is the issue? Okay. Actually, what we have to do here, we have to write n. Actually, just a small change we have to do. Since what it is saying that it doesn't understand what is n here, this value. It doesn't understand what is this value. So that's how it is creating the issue. So it doesn't understand that what is this value. So so what we have to do, so definition factorial 2 while actually we have to write this somehow. N is equal to n. This is actually local variable, so it doesn't understand this inside this value. So x is equal to 1. How to write it? So x is equal to 1 while n greater than 1. So it doesn't understand this value. X is equal to n into x, n is equal to n minus 1. Okay, so okay, factorial to n. So what we have to do is, so this way actually we need to little bit think that how to write this quickly. So actually this is a local variable, so it doesn't understand n inside the here. So that is the issue. This is, it doesn't understand n. Okay, so no issue. So I'll write it. So don't worry, I'll write it. So just we can move further. So that we not to stuck with this. But you can try writing the factorial function by using the for loop. So I'm just skipping for timing, so that just we don't want to spend unnecessary time on this. This is, you can try yourself. So what we do, we move further and then we go to the another important thing, that is the if else statements. If else statements. So if else statements work like this. So let's say I have two number, x is equal to 50, and let's say you can write y is equal to 20. So I have two numbers, and then I want to just put the condition. If let's say x is strictly less than y, then what you do, you basically print the statement that, and in form of a string, that x is less than y. You write it this way. Then you go further, and then there is a elif. This is called basically elif. You can write here x is equal to y. So remember that we put two equals, not x is equal to y. X is equal to y is used for assignment, and x you have to put double equal sign, that is used for comparison. So remember that this x is equal to 2, that is assignment. This is not a comparison. but x is, this is a comparison here, not assignment. So you have to remember assignment. If x is equal to y, then you have to write, I can copy this to save the time. So you can say x is equal to y. Then since we have almost done, so you can write the final thing else, and then you can write here x is greater than y. So this way we have completed everything. So you have x and y, those numbers, and then you have the if else condition, and it will check these condition one by one, and then it will print the appropriate condition. So it's saying x, what it's saying, y is equal to 20. What is the issue? So now it is working. So x is 50, y is equal to 20. So based on this, it compare all these things, and then it print that x is greater than y. Since we have made the loop in such a way, we have made the if else statements in such a way. So if else statements are used very often when you have to like check and you have to print something. So it is very often used. So hope you understand if else statements. Okay. So these are important. So today we have covered the till now the for loop, the while loop, and the if else statements, right? Now what next we want to cover is that in Python actually what you have is you have lots of inbuilt libraries. So I am writing some important inbuilt libraries. So we have to start using them. And then we can do many things actually by using those library, inbuilt libraries. So you need not to write everything yourself. That is the good part. Inbuilt libraries. So important one include, let's say, as we discussed last time, math. We have used math library last time. We have discussed a little bit about matplotlib, and there is Numpy. There is basically Pandas. So these are used for different kind of data types. And then you have your sklearn. You have your, let's say, scipy and others. So we start discussing with Numpy first. So these are the important inbuilt important libraries that you can use. So math we have used little bit. So math is you can all the mathematical operations you can do using the math library. So we start with the Numpy. So Numpy generally is used for the matrix. Since when you learn Python, so many of you may be interested to work with the data. You want to go in the area of data analytics. You may want to a data scientist. Even many you want to do some, let's say, project. You want to do your PhD. So there are different kind of functions available. So that's why you want to explore first the Numpy, and then from Numpy we will move to another libraries that will give you some exposure. Okay. So generally what we do, we have to, as we discussed last time, that you have to call the library. So you have to call import Numpy as NP this way. So what we are doing, that we are calling the Numpy library by this command, but as a short form, as NP. It shows that this is a short form. So we can write here that NP is a short form. Is a short form. So whenever I have to use Numpy, I can use just NP, and that will help me. Okay, so the first thing that is a fundamental thing in NumNP is the arrays. Arrays basically are like vectors. You understand vectors or arrays. So these are different from the list. They are called array. So you can create array here. So for example, the vectors can be called as arrays. So these are array actually. This is the np dot array. We can create a array like this. np dot array. And generally what you have to do, you can pass this inside this as a list. But this is not a list, but this become an array, numpy array. So you can see the type of X as we discussed last time also, that what kind of object it is X. So this is a numpy.nd array. It's called n-dimensional array. So this is not a list. This is not a tuple, but this is an array. So generally what happens that it can use NumPy can you operate arrays very efficiently. So there are operations that it can do very fast. So whenever you have to work with the vectors kind of thing, so you don't use the list. Since list, the operations may be slower, but NumPy array are written in such a way that this matrix operations, vector operations, these are very fast, inbuilt very fast. So that's why you can use it. Now again, you can find the element from this similar to the list. So let's say x0 is equal to 1. Similarly, these elements have index, and then if you pass the index, so I can write that. So what you have to write is, so you can find the different elements by using the simple, similar to the list or tuples. You have to pass the index and you can get the value. But there is much more here. This is not just finding the index. You can do many things. And if you want to see the functions that are available in NumPy, so you can see np dot, and then you have to press the tab button. So you can see that, okay, there are so many functions here. So many functions that you can do in NumPy. They're all, even whatever the mathematics functions are also here, exponential and other things. So you can see that there are so many functions in NumPy, and these functions you can use actually for your purpose. There is a huge list of functions here that you can see matrix multiplication, matrix maximum, and something. So for example, right, so this is a, then what we do, we can check the shape of this vector. This is a shape of this array. That is, there are 5 elements here. So there are 5 rows only in this, 5 rows, right? That's why there is nothing here. You can create a 2-dimensional array just similar to that. So this is a, we call this kind of thing as, we call this thing as 1D array. Basically, this is a 1-dimensional array. I can create a 2-dimensional array also. So I can create a 2D array like this. Y is equal to np dot array, and then what you do, you have to pass inside these values like this. So you can see that I have created first a list within, there are 2 lists within the list, and then I have to pass to the array. So I say that 1, 2, 3, 4, 5, this I can create. And then you can have 6, 7, 8, 9, and then 10. Let's say they have to have same shape. So these are 5 elements here. So 5 elements here. So this is a 2D array. So how do you look like? So this is like, as you understand, like a matrix. So you have the first row, and then you have the second row. You know that in matrix there are rows and columns. So you have your rows and columns. So you can check the shape of this, that it will show what should be the shape. And shape will be, there are 2 rows and 5 columns. So the shape is 2 into 5, 2, 5, 2 rows, 5 columns. So this is a row and this is another row, and there are 5 columns. Okay, so now how do you identify the elements? Suppose you have to use these elements, how you use them? So let's say I want to calculate the element 0, 0. So what will be this element? So these rows and columns are indexed by starting from 0 to, so there are 2 rows. So row index vary from 0 to 1. Column index vary from 0 to 4. So there are 5 columns. So index vary from 0 to 4. The row index also vary. There are 2 rows. So row index vary from 0 to 1. So 0, 0 basically means that this is the first element. This 1 is the 0, 0th element. This is the 0, 1th element. 2. This is the 3 is the 0 and the 2 element. This is the 0, 4 element, and then this is the 0, sorry, this is the 0, 3 element, this is the 0, 4th element. So 0, 0 will be 1, and then we can see it. Then similarly, if you find out, let's say 0, 4, so this will be this element, this 5. And then similarly, you have 1, this means the second row, and then if I pass here 3, so this will be this element here, 9. Since index vary like this, so 1, 3. So this will be my 9. So in this way, you can extract the element from the this array. This basically 2-dimensional array. And you know that 2-dimensional array, you can convert to them as a matrix. We want to make this as a matrix. So if you are working in linear algebra, so you can make this as a matrix, and then I have to pass y here. So y is a 2-dimensional array, but it can be converted to a matrix, and so that we can apply the matrix operation on this. Right? So np dot matrix, I can basically make it, and then my matrix is this one. So this is, so mat is not an array now. This is a matrix. So that is the, it look like similar, but this is not a array now. If you see the type, that is important to check every time. So this is a matrix. Earlier it was an array, now it is a matrix. And now when it become a matrix, so you can use the matrix operations. That is a good thing. So for example, you can have mat dot, what you can have the operation? Matrix, you can have transpose, right? So what is the transpose? You can make this transpose of this matrix. So this has transpose. So transpose basically means this row become the column and column become the row. You can calculate the trace, but trace, so there will be, this is the trace. And then you can have, if you have a square matrix, for example, I can define a square matrix. Let's say first I have to define z is equal to np dot array in this same way. And then what I can do, I have to define a 2-dimensional array. And then I have to pass extra this list within to list. So I can say 1, 2, and then 3, 4. The good part is that if I have a square matrix, I can try to find the inverse of this. So matrix, another matrix I can make it. So np dot matrix, and then I can say that I want to make this is a square matrix now. So then you can find mat1 dot inverse. inverse, or you can find here np dot matrix. Okay, np dot inverse. We need to see whether where is this function inverse. Invert, yes, and then we can say mat1. Hopefully it should do the work. So this is the inverse of the matrix. So in this way, what just I want to say is that there are whatever function you can think in linear algebra, they are linear algebra or matrix operations, they are available here. Only thing that you should know how to use them. So Numpy is a very rich library, and you can do very good operations here. So now just to give you some more flavor that what is available in Numpy. So just first thing that we have discussed is the one-dimensional and two-dimensional array. And you know that two-dimensional array can be converted as a matrix where you have rows and columns. And once you have the matrix, you can use whatever matrix operation you can think: matrix multiplication, matrix inverse, transpose, trace, rank. You can find all those things. Since you are engineering, mainly engineering graduates, so you understand that matrix operation. So these are important things. And whenever you go for data analysis, these things are also important. Next thing that we want to do is, if you have studied some random numbers, so you can generate random numbers here. So random numbers we can are also helpful to understand the things, random numbers. So you can understand random numbers from different distributions. So let's say I want to generate np dot random. There is a function here, random dot. You can have different distribution actually. Let's say if I tab, so you have beta distribution. Those who maybe you have all done a basic course in probability, and you know that you have chi-square distribution, you have exponential distribution, you have f distribution, you have gamma, you have normal, gumbel, hypergeometric, Laplace. All these distributions are available here. And then let's say the very standard one is the normal distribution. So we take the normal distribution. So you have to pass the mean, you have to pass the standard deviation, and you have to pass how many random numbers you want. So normal distribution decided by its mean, variance, and the numbers that you want. This one. And then you generate these numbers. Now you can visualize these numbers. So how to visualize these numbers? So I write visualize these numbers. So how to visualize these numbers? You can see as a histogram. You know that, right? So in histogram, we have to call the matplotlib library. So import, as we discussed last time, plotlib.pyplot as plt. So this way we have the matplotlib library, and then you can call plt.hist, and then you can pass x here, and then you can say there is a bins actually, how many groups you want to make, that is called bins. And let's say we want to make 20 groups, and color that we want to put for this is, let's say, blue. So blue color, and that's how we want to make it. And then you press it, and then you see that, okay, so this is the histogram that is coming from the data. So remember that we have generated random normals here, and then we have basically created the histogram out of these numbers, and then you can just see it again. This is the, so it look like a normal curve. So those who have studied probability, they can easily identify that this histogram look like a normal data, normal distributed data. So what we have done, we have basically taken some data that is a synthetic data, obviously, which is generated by using the normal distribution. And then that data you can visualize by using the histogram. Similarly, you can have very good, basically, let's say scatter plots. So what you can do, then you can visualize also the scatter plots. Scatter plots. So what you can do, you can again generate x is equal to np dot random dot normal, and then you pass 0 1, and then you generate 1000 random points. And similarly, I generate another variables random dot normal. These are different than this since we are generating them separately, 1000. And then what I can do, I can do basically, I can do the scatter plot, plt dot scatter, so that you can see that okay how they are look like when two vary together. So you can see these points look like this, and those who have little bit understanding about the scatter plot, they can see that these data points essentially are uncorrelated. Uncorrelated basically means they are distributed in such a way that they make like a circle. So these are uncorrelated data points. You can increase the size to see that okay more here. So these look like a circle, and so these data points are uncorrelated one. And how you can check it? So there is a correlation function also in here, np dot correlation. So you can see here correlation coefficient or correlate. I think this should be the function. So you pass here, it calculate the correlation between two. Oh no, it's I think doing something else. We have to use the general function correlation coefficient. Correlation coefficient, this one we have to see, and then you can see that okay here there is a very low correlation between them. These are correlation between this on the diagonal, it is x versus x, here it is y versus y, so there is a one correlation, but xy is in the off diagonal, so that is close to 0. So in this way you can see that we have used the numpy function to generate first random numbers, and then you can see you can use them. Okay, so I hope now you can explore more about the numpy library, and numpy library is very rich and it is very helpful. Okay, now what I do further is that one more thing that I want to do, that is we explore the library that is called Pandas. So NumPy, actually there are many functions, so obviously I cannot cover all the functions, so you have to explore it more. So it depends actually what you want to use, which functions are more important for you. So when you start practicing, you remember those functions, you recall those functions. So there are so many functions. One very important function again here is just I want to tell that also, that is arrange function. So what it does, let's say x is equal to np dot arrange. This arrange function, this one. So what it does, if you want to between 0 and 5, let's say np dot arrange 0 and 5, and then you want to generate numbers with the interval 0.5, 0.1, sorry, then you can generate these numbers. So you can see that what is x here. So it starts from 0, then second will be just 0.1 difference it create, then again 0.2, 0.3, 0.4, 0.5, so on. and it basically go till 4.9. The last point it doesn't include. That is a common practice in Python. So even you can make it, let's say 0.01. So in this way, it will generate by the interval of 0.01. So this function is very helpful. So I have to do it. So in this way, you can say that you have generated these points, these many points. So these are with the difference of 0.01. You start from 0, then it go to 0.01, 0.02. Now, how this is helpful? So yesterday, it is very helpful in plotting. So this function, this arrange function of numpy is very helpful in plotting. How it is helpful in plotting? Let's say you want to plot the exponential curve. So what you have to do, I can generate y is equal to, so as we discussed last time, that you can basically plot a function first generating x and then generating y. So I can use x here and then I can calculate np.expx. So it will give me the value of y for all possible x that are given here. And then I have x and y, and then I can get my plotting. So for example, this is my y, and then I say plt.plot, and then I say this is my x, and this is my y, and also I want this thing that will show me all the points. Okay, what is this? This should be the case. It should go inside this, I think. So this is the function, exponential function that we have plotted. Right. So if you want it little smaller, thicker, you can use this. So in this way, this is the exponential function that we have plotted. And obviously, as we say that you can give the labels plt.x label. Last time as you discussed, you can see the x-axis. This is in your head, how you want to decorate it. This is the decoration part that you can do with there are many functionality available. And then you can say this is my y-axis. And I can say that my title is this. This is a exponential function. So once you can decorate it in this way, and then you will get the function like this. You have x-axis, y-axis, exponential function, and you have this function here. And the good part is that you have exponential function, you can create a sine, you can plot the sine function also in the same way. So just what you have to do only, you have just y is equal to np.sine, and then you can have the x. Whatever complicated function you can plot, we are just plotting the simple one, and then you have to, I just copy this code again and I paste it down so that I have another function ready for plotting. And then I just change this thing here. This is a sine function. And then you have this function here. So it is plotted in the range 0 to 5 only. If you want to change it, you can just create here. If you want to change it, you want also negative part. What you can do, I can just change my x first. I can generate a separate x that I call np.arrange, and then I start from minus, let's say 5 to 5, and then I want the interval 0.01. In this way, first I have to generate x and y, and then my function will be like this. I have this, the sine function. Sine. Okay. So this is my sine function. I can float it this way. So you can have very complicated function that you can float here. Just you have to generate first x, and then you can generate the y. For example, let's say many people find it difficult to float the log function. Log function. So only thing is that in this case x has to be positive. So np dot arrange. You can have arrange, and then you don't want the value close to 0, since that becoming log very large value, so it can create the problem. So we start from 0.01, that is very small value, and then you go till 5, and then you want 0.01 as the interval. So this is your x, and then your y is equal to just np dot log, np dot log. So you have to see what is log. So log 10, this is log 2, there are different base. So this is the log e. And then you have to pass x here. So this is my x and y, and then just you have to load. You can copy there whatever we have written earlier, this part, so that we can plot the log function. And then you say the natural logarithm function, and then this is my log function. So hope you understand that. Now what we are doing, so earlier we are discussing the library and everything standalone. Now what we are doing, we are mixing different library. So in this plotting we have used NP, and then we have used matplotlib, we have used the strings and other thing in writing the x-axis, y-axis. So that's why you need to understand different library, and then your ultimate work that you want to do, that needs actually all the libraries. It is not just one single library will help you. You mix actually the functions from different library to get the desirable output. Okay. So hope you are able to. So far what we have covered the loops, for loop, while loop, and then we discuss about the if else condition, and then we work with the Numpy library. And in Numpy we have discussed array, single one-dimensional array, two-dimensional array, and then we move to, let's say, matrix. You can have matrix operations, and then we move to generating random numbers, that where you need you can use np.random, and then you can generate from different distributions. So those who know probability, they understand all the distribution names. So you can generate random numbers from different distribution. And then you have plotting, matplotlib, and then we have used arrange function to plot different kind of curves. So you can do all these plotting part. And obviously I'm going to share all these things with you so that you can practice and you will be good in Numpy. So another important thing that we want to discuss is the Pandas. So Pandas also is a very important library, and which basically work with the time series data and data frames. So Pandas is a very important Python library, deals with time series and data frames actually. So again, how you call it? First thing that whatever library you have to use, you have to import it. Import pandas as, we can give a short name, and generally PD is the standard name that people use. Import pandas as PD. Many people use this name. And once you have, sorry, there is a spelling mistake here. So this is PANDAS as PD. So this way you have to write it. So now we have the pandas library available to us. Now what I have, so before we start with this, we want to read some data from our computer. So since then we can use it on that. So generally what happens when you work with some data, that data is stored on your computer. And you have to read that data from your computer to call it in the Python environment. And then you basically manipulate or whatever you want to do with the data, you do it. So I have a data on my computer that I want to call. I want to call in Python environment, that is in a CSV file, .csv file. You can have Excel file, you can have CSV file, and you can have many different data types, many files that you can call here to manipulate them. So I have a file and I want to call it. So generally what we do, we call it in some variable that I'm calling data, or you can call X also, Y also, whatever you want to call. And then you have to use there is a function that is called read. These functions you can use actually, different kind of file you can use. So I have a CSV file. So that's why I want to use the CSV function. If you have an Excel file, you can use the Excel function. If you have HTML file, you can use HTML and other things. So what I want to do, I want to use the CSV file since I have a CSV file. So I call this, and then I have to give the path. I have to give the path of my file. And what generally we do, we go to our file and then we do the right click, that file I want to call. And by doing the right click, what you do, you get the properties. And in properties, what you have, you copy the path. So you know that every file has a path. So if you don't remember the path, so that's why you have to go to the file. You go by right clicking to the properties, and then you have to pass that path as a string here so that you can read it. So I can call. So this is my path on my computer where I have a file stored there. And then I have a file name, that is the data type I want to call, advertising advertising.csv. So this is the path of my file, and advertising.csv is the name of the file. This is the name of the file, and this is the path where my file is stored on my computer. So I have to tell it everything since it doesn't understand where the file is stored. So that's why you have to give the path. Or one thing you can do, that if you are using, let's say, Jupyter notebook, you can upload the file on Jupyter, and then automatically you need not to do the give the path. It automatically search in the local folder. But if your code and your file are in different folder, then you have to give the path. If they are in the same folder, then you need not to give the path. You can just tell the name of the file. It automatically search there in the local folder. So that is the difference. So we have file on the desktop and we are working in different folder here in Jupyter notebook. So that's why I have to give the path. And then this is, you can see now my data. So this is the data that is stored on my computer. So you can see that it cannot display everything. So it display the first few rows and then the last few rows. Between the rows, it cannot display here. This is a shortcut that they use to display only the first few rows. You can see by looking the first row by using the head, and then you can see how many top rows you want to see. So these are the top rows, 5 rows. Head 5. I have asked only to show me the 5. So it is the head of the data. So you can say that this is the top 5 rows that I want to see of the data. So that we have seen. You can see the bottom 5 rows, bottom 5 or 10 rows, you can say, even not 5, let's say 10 rows of the data. You have to write data dot actually tail. So head and tail of the data, and then you have to pass the number that you want to see, and this is the last 10 rows of the data. In this way you can see the data. So in my data, this column is unnecessary, unnamed 0. This is coming just unnecessary data. This is not required. I have only these 3 columns: TV, radio, newspaper, and sales. These 4 columns. So I can drop it. I want to remove this column from my data. So I create a data 1, that is by removing the data dot remove data dot delete or whatever, del data dot drop, actually I think drop. So I have to drop. So I want to drop this column. So I have to give the name of this column. This I don't want actually. This is unnecessary here. So you have to give the name, and then you can give the name this column. Hopefully it should drop it. So now your new data, okay. Data 1 dot row. Let me see here. I think it should be like this. Okay. I have to, actually there are, okay, data dot row. So let me see actually. So I actually am forgetting the command. So there are so many commands, you cannot remember them. So you have to, when you are keep using them, you remember the things. Otherwise, either you have to take the help also sometimes. So let me see if it can get from the help. So you have to tell it axis also. So you have to tell it axis. So you have to tell the axis. That's why I have to. So what you have to give, you have to tell the axis. So I have to tell the axis, then I can drop it. So I didn't tell the axis, that's why it was not able to identify it. So data 1 is equal to data dot drop, and then you have to tell the name, the list. Hopefully it should work like this. And then you have to tell the axis is equal to 1 actually. So you have to tell the column name that you want to drop, that we have tell, and then you have to tell the axis actually. So there are 2 axes in this data frame. One axis is these one, this one, and then the column names are the axis 1, and these are the axis 0. So you have axis 0, which are the rows numbers, rows names, or axis 1, that is the belong to the columns. So it's saying that you have to, it is looking in the columns now, and then it will drop that column. So this is the new data. Okay, so what generally you have to do, once you are essentially have the data in your hand, then you can do many things. So you want to study maybe this column, the first column, TV column, you want to study the radio column, you may want to study the newspaper column and others thing. So we can start looking at the data and how to read the data from this. So if I call, let's say data 1, and then I pass here the word TV. So this means I am looking at the TV column only. So this way I get a TV column, this column. I have the index, I have the values. So this is my TV column. I can change it to radio and then I get the radio column. So this way you pass the column names and then you can get the columns. Even you can pass here 2 columns. So you can pass here, let's say TV and then comma, and then you can pass here the radio. Sorry, so this is this, this, and then you have both columns. So in this case, we have passed the 2 columns, name, TV and radio. So you have both the columns, and then that's you can select the data like this: TV, radio, name, and then you can have just in this case we have. Then similarly, you can select from here. Let's say I just want to select the second and third index here from here. So I can tell these name also. So in that case, I cannot use this function. I have to use, there are 2 commands. That is important command that is called iLook. iLook in Pandas. iLook in Pandas. So this function we have to use. So how it work is that you have to first use the data 1. So I work for index and look for the location. So in that case, there are entry are like this. So for example, I can tell, let's say I want to select these values. So these values are with the, what is the index for them? The index for them is 195 and 196 on the x-axis, this row axis, and then TV and radio on the y-axis. TV and radio, but TV and radio are, we have to give the numbers actually. So if you see here, so TV is 0, radio is 1, newspaper is 2 in terms of numbers, and sales is 3. So that you have to do. So then what I can do, I can say that, okay, I want these numbers. So what I do, first thing, I pass 195 and then 196. This means this is the first entry, give the rows, and then the second give the columns. So column means if I want 0 and 1. So this will give me these entries. This one we have selected. So this one. So you have the first thing, you have the row numbers here. You want 2 rows with number 195 and 196, and you have the column numbers. So the first column has number 0, the second column number has the 1. So that's why we select these entries. Obviously, if you want to include 197, you can pass here 197, and then obviously 0, 1 will be there. So you will have now 3 rows. So 195, 196, 197. So this is a subset of the data. So by using this iLook command, you can, let's say you have very large data. There are thousands of rows or millions of rows and millions of columns. So in that case, you may not want to work with all the part. You want certain columns. So then you can call only those columns and then you can work with them. So this Pandas particularly give very, very good functionality for data frames. So this data type that we are discussing is a data frame. So remember that this is a data frame. So you can see pandas.core.frame.data frame. So this is inside like this is a hierarchy actually. You can see that this is inside pandas and there is a sub module code, then in that sub module another sub module frame, and then you have a data frame. So there is a hierarchy and that's why they keep writing with the dot. So pandas is the, let's say, library, then in pandas you have another thing code, then you have frame, then you have data frame. So that's how it is. This is the hierarchy that is available with this. Next thing is you can work with this. So generally what happens that if I explain this data 1, so you want to see whether TV has a effect on sales, whether radio like spending money on radio advertisement has a effect on sales, whether spending money on newspaper advertisement has effects on sales, or so that's is your aim. So what you can do, you can then what you can do, you can basically do the plotting part here. So we can do certain plots here. So for example, as we discussed, so we can mix another library here, scatter plots you can do. So scatter plot, what you have to do is just you have to call the library plt.scatter, and then you have to give your data 1, and then data 1 you want to work with the TV, and then you have to data 1 you want to plot it with the sales. So that is the way you work with this, and then you can have the scatter plot of this like this. Obviously you can change the name here, plt dot let me just put quickly, x label is your TV spending, and then plt.y label is basically your sales, and then you have plt.title, that could be your advertisement. So in this way you can just decorate it a little bit. So what we are doing that now you remember. So what we have done. So why we are doing this? So in this case, first, when you are working with, let's say, on some data, you have to read the data from your computer. So first thing that we did, we had a data in our computer. We read it by using the pandas.read CSV command, and then that data comes to our Python environment. Once that data is available in a Python environment, what you do is you see whether you need which columns are important, which are not important. So you draw. We draw some column that just randomly added in the data due to maybe data error or whatever. So we have removed that column. Then you can use, basically you want to see whether there is a relationship between TV spending and sales. So that's why we do a scatter plot. You can see that if you spend more on TV advertisement, then your sales increase. Since there is a trend here, increasing value, this is an increasing trend. So that is the conclusion you can get. So that's why you start, this is your first step towards some sort of data analysis. First step with data analysis. And then just I quickly, again, I just take from here and then quickly do the other plots, and then you can see that which is more effective. So another plot I can take here, just radio, and then I can say here radio spending, and then you can see this chart. So you can see that however there is a still increasing trend, but there is some variation here. There is some trend for some markets, and there is no trend in another market. Data points represent different markets actually. right? Then you can have your newspaper also, newspaper, and then you have your newspaper. So you can see that there is not much trend here. This is like a only circular data. So there is not very good correlation between them. And that's how you can see these things by the correlation also. So if you see, there are simple commands, like let's say when you want to start an analysis, so there are functions that you can directly use. So there is a one function data one dot for a data frame, it is available describe. So this give all the basic statistics of your data one to describe. This is available with all the data frames. So you can, if you use this one, this function simply, it give all the important statistics about the data. So what it's saying that in TV there are 200 data points, radio also 200 data points, newspaper and sales. Then the mean of TV is 147, that mean spending. Mean spending on radio 23, that is available with your data 30, and the mean sales is just this 14. Their standard deviation, their minimum value 25 percentile, 50 percentile, 75 percentile max. So all these statistics you can get by just one simple command, that is describe here. So in this way you have your describe function that you can use. So if you see here, if you go back, you can see that you read the data and then you can do many analysis with it. And similarly, what you can do if you want to save your images, so you can save your images also. Suppose this image you are looking at here in your Python environment, but you want to save it. So what you have to write, so let me just call it this image again, and then I want to save it. So what I want to do is save the image to the computer. You want to save the image in your folder. Since whatever image you have created, you want to use it later. But if you close this, the image will go. That is just for your local purpose. But you want to save it. So what I have to do first, I use this, and then I say that plt.savefig. And then you have to tell savefig, you have to tell the path. So what path I want to take, I can take the same path where I am having my data, that I am copying it from here this way. I want to use this path, and then I want to save it in my computer. So I give the path here. Obviously I have to give the name. So I say that I give the name here. I can give the name newspaper sales dot, and then you can give the name whatever kind of file you want to save. I can call this jpeg file, and then I close it. And so this file will be here, but it also will save in that folder. This file will be saved to my folder. Just you have to write plt.savefig, and then you have to give the path. And then if you can see this folder, so this is available in this folder also. This is available in my folder. I'm not sure. Let me just use here. So I can say this. So this is available in my folder. So this is also available in my folder, this image. And then, so this image is available in my folder. Similarly, if I have something that I have done, so you know that data we have read from our computer, but data one we have deleted one column. So now we want to save our data one to the computer that we have changed actually. So data was the original data, that data was the original one. And then from data, we have removed one column that become our data one. So, but we now want to save our data one to the computer, right? So that what you can do, you can say data one dot save, sorry, or I have to see pd dot save. I think it should be uh, pd dot this is a command actually I'm forgetting. So data one dot two, two CSV like this. So you have to call the data frame name, and then you have to tell which kind of file you want to make it. So there are different kind of files. So we want to make it as an Excel file. So I can call this data2.excel, and again I have to tell the path. I have to tell the path, and then I can say that advertisement dot exlsx, that is the file type of Excel. So now I want to save data one to my computer where I have manipulated it. Earlier it was data and then it become data one, so I can save it to my computer. So it will save to my this folder again after manipulation. So this means that you can read the data in your Python environment, and then after manipulating it by some rows and column operations, you can basically save it back. You can save back your figures, and then you can also save back in different format. You can make it PNG file, your figure, it could be JPG, it could be TIFF file, it could be other format. So that you can do. So Pandas is a very important library, which basically you can use for, let's say, many purposes, and particularly to exploit the time series data, and then the basically data frames basically are the data which are in form of again rows and columns, but these are no rows and columns. You also have matrix, but matrix are different, data frames are different. So Python treat matrix differently, data frame differently. That's why you have to remember that which kind of data you are using. That's why every time we check by type that which kind of data you have. So that is important. Now just we have some time, so I want to do some exercise where we again manipulate some data, and then I'll share this new screen with you. So okay, just give me 1 second. Okay. So in this, what I want to do, I want to work. So you know that whenever you have text, let's say book, whenever you have a book, so you know that all the alphabets that you are using in the book. Let's say I have a name Arun, Arun. So in this case, A is there repeated once, R is repeated once, U is repeated once, N is repeated once. Arun. Now if I take my full name, Arun Kumar. So in this case, R is repeated two times. In one in Arun, another is Kumar. U is repeated two times. A is repeated two times, and so on. K is repeated one time. So in this case, if you have a large book where you have different words and different things, so what do you expect? What do you expect? Which alphabet will be repeated, will be used more time than the other one? Okay. So to check that, what we do, we take a book, and we basically read all the sentences in that book, and then we count that how many times, since all the if you see the whole book, if you remove the numbers, it is whatever word you use, whatever sentence you make, they are made of just from the 26 English alphabets, right? A, B, C, D, E, F, G, H, and so on. So we want to check how many times A is used in the whole book, how many times B is used in the whole book, how many times C is used in the whole book. So generally you can guess that the vowels and the consonant. So vowels will be more often used than the consonant if you write a book. But which vowel will have the larger frequency and which vowel, which consonant will have the lower frequency, you can check it. So that exercise we are doing here. So what I have done, we call Numpy, we call Pandas, and then there is a function that is called open. So by using open, you can basically open a text file. So this is a txt file, where txt file, it has, this is the whole book, whole txt book. So we converted PDF to txt, and then we are reading it from my computer again. And then there are different encoding kind of thing where it can code special characters and all those things. So this book we read, and now in that book, due to some commas, apostrophe, and other thing, we can remove those things from the book. And then we are delete list, we are basically removing these from the book, these things that, you know, in book, if you write a sentence, there could be, let's say, apostrophe, there could be comma, there could be semicolon, there could be full stop, so those hyphens and other things. So we want to remove those things from that book. And then this is the procedure that we are doing here. Now what you do, you essentially from that book you read. So for this is the way that you read from the, when you open a file, you can read by using this command, for line. We have already covered the for loop. So for line in the F, which is the book you have opened, this is the app object, app, and then, and for word in the delete list, whatever word is in this list, that is a for loop. Then you can replace those words by some, just by this one. This is also a string, but this is a without white space string, this is string. And then you can add this list all the lines, and then you close the file. So this means LST have basically, so if you see, so insert, let's say cell below, so we enter the LST, and then if you want to read LST, you can see that how it look like. So this is the whole book that has converted to just the words. Actually, this is the list from here. So you have shift enter, and then So this is the whole book where you have merged all the values, and even you can see that there are some still X, this kind of things are still there. You can remove all these things, but that is also you can do. There are special characters that are coming. You can remove all these things if you want to remove that, but we have not removed those things. So what next we do? We make this as a final string by joining actually all these things together. So basically what happens is in the list, there are different sentences. So this become our final thing that we want to study. So you can see what is the form of what is the form of final string. So insert cell below. So you can see this also. So in this way, now we have removed different parts, and then you can see that this become a like continuous text. We have removed everything now in the joining part. So by using this command, you can join different strings actually. So this is the final thing. Now still you can see that there are capital letters, there are small letters. So we want to remove that also. So what do you do in removing that? You say that final string is equal to final string dot lower. So last time we cover upper and lower in the string. So upper make every alphabet to in the capital letters, and lower make every alphabet in that particular string to be the lower letter. So we have converted everything to lower letter. Now we want to check. We have some just said key is equal to A, B, C, D, F, G, H. Since everything is made of these basically 26 alphabets. So we have this, and then we want to create a dictionary. So you know that this is the empty dictionary, and then you have for item in keys. You repeat. Let's say for A, you check, you count how many A's are there. So you count the percentage actually. So round is used for the round figure for 2 decimal point. That's why this is round 2. So you can see that what is the round means actually. So there are different. So let me just show you what is the round means. Insert cell below. So let's say you want to use round function. What is the meaning of this? So round is, let's say you are calling 2.33333, and then you are saying 2. So this means that it will write just 2.33. So that is the meaning that this round is doing. This round is doing. And then what you are doing, you are counting the number of A in this whole string. Count function we used yesterday also, that how to count whether some alphabet is in a string. So that is here this count function, and then this length function counts basically let me just also tell you what is the length function. So length function count this length of a string. So it count how many alphabets are there. So there are 13 alphabets there in this string. That's why this is the count function. So what we are saying that how many times A is there divided by what is the length of the string into 100. So you want to check the percentage, and you round till decimal 2. That's what this function is doing. And then this is the final result. You are saying that A is repeated 8.49 times. This is the percentage. This is a 8. So roughly 8.5% times A is coming in that book. B is coming 1.65. C is coming this. So E is coming E. If you see E is coming 11, roughly 12% times. And then you can see that A is a vowel coming very often. E is a vowel coming very often. A, E, I is also coming good times, but not that bigger. O is coming 7.6% of the time, and U is coming 2.63% of the time. So the highest repeating things is the E. So you can see that this is the universal fact that E basically comes very often in any, if you see a large text, that is very common. So Z is coming, let's say, you see that this is the lowest frequency Z is coming in a text. X is coming only below 1%, Z is coming even below 0.5%, and Q is also coming just around 0.5%. So obviously, if you go to China, then Z may be coming very open, since Chinese use Z very often, X also very often. But if you see other English names or other English text, X and Z are coming not very often. And then we can basically plot a histogram to see that in here. So this look like this. So you have A, that is, this is the corresponding height. You have B, you can see that E has the highest height here. So E is coming very often in the text. And then you can C, F, G, H. So whatever the height are coming, T is coming actually also very good number of times, T in the text. And then you can see X and Z very lower number of times. Then similarly you have Q is here. J is also not coming very often. So J, Q, X and Z. J, Q, X and Z are coming very less often in the text. So if somebody asks you general knowledge question, or it may come, people may ask, so you can understand now that E is the highest, has the highest occurring frequency in a text. And then J, Q, X and Z have low. Then similarly V also have low, then K also have low, B also, then and then highest comings are, let's say, A, E, H, I, then you go N, O, then you have S and T. So these are the highest occurring, you can say, alphabets in a large text. So you can see that whenever you have to do something, so you have to use multiple libraries. So for example, in this case also we have read something, then we have used the operations on the strings to basically merge all the words actually in the text. And then from that we have to use the functions from the string like count and other thing to collect the data. And then we can use the plotting functions to see the histogram and to see a chart so that we can summarize the result. So this way, what we are doing, we are merging actually different libraries to get the desirable output. And so that is the case. Okay. Okay, I think so. I'll will stop here. So maybe